Dear students, in this module you shall learn what are tandem reactions, understand different types of tandem reactions, study the stereoselective synthesis by tandem process and understand the concept of domino, cascade and tandem catalysis. We would also have an insight into the Kharash addition. Tandem reactions involve the formation of several bonds in sequence without altering the conditions of the reaction, adding different reagents and isolating the intermediates. It is a sequence of intermolecular organic reactions which often proceed via highly reactive intermediates. It allows the organic synthesis of complex multinuclear molecules from a single acyclic precursor. The substrate contains many functional groups that take part in chemical transformations one at a time. Often, a functional group is generated in situ from a previous chemical transformation. So, tandem reactions are commonly referred to under the nebulous phrase multi-step one-pot reactions. However, most descriptive definition is tandem reactions are combination of two or more reactions in a specific order, and if they involve sequential addition of reagents, the secondary reagents must be combined into the products. Advantages of tandem reactions. There are several advantages of a tandem reaction over the series of individual reactions. Firstly, complex structures can be formed in fewer steps by tandem reactions. They eliminate the need for a purification step or steps. It is always very difficult to isolate sensitive and unstable intermediate, but in tandem reactions there is no need to isolate the intermediate and hence making the reaction easier. Employing reactions in tandem will reduce the cost and amounts of the reagents and solvents. It also decreases the amount of the waste generated. Let us look into the classification of the tandem reactions. Chemists have grouped the tandem reactions into three categories. First, cascade or domino reactions. The first is cascade or domino reaction, in which both or all the reactions takes place without the need for the additional reagents or a change in reaction conditions. Anything that is necessary for all the reactions is incorporated into the starting materials. Second, consecutive reactions. The second class of consecutive reactions is where the intermediate formation is in the first reaction has the necessary functionality, but additional energy must be added in order to overcome the activation energy barrier. Sequential reactions. The last or the third class is the sequential, where the functionality for the second reaction has been created, but additional reagents must be added in order for the second reaction to occur. Stereoselective synthesis of bicyclic gamma lactams by tandem process. Tandem process is a novel method to synthesize bicyclic gamma lactams stereoselectively. In this process, trichloroacetonitrile reacts with an allylic alcohol in the presence of DBU, 1,8-diazabicyclo-undeca-7-ene, a catalyst and a complexing ligand, which results in allylic trichloroacetamidate. Finally, Overman rearrangement, which is RCM, or a Kharash cyclization of allylic trichloroacetamidate, forms the desired bicyclic lactam. The overall process involves three distinct processes, which are catalyzed by palladium and group's first generation catalyst. The main advantage of this process is the high yield and high enantiomeric excess of the desired product. The outline of the reaction is shown here in the figure. To accelerate the synthesis of the desired bicyclic gamma lactams, a microwave assisted tandem process has also been developed. As shown here in the figure, a number of commercially available drugs, as shown in figure, can be synthesized by this two-step tandem process. since the core unit of these drugs is closely related to the bicyclic allylic amides. Domino cascade catalysis. Cascade or domino reactions do not require additional reagents or change in the reaction conditions. Tietze also defines domino and the cascade catalysis as a process in which two or more bond forming transformations take place under the same reaction conditions without adding additional reagents, and in which the subsequent reaction results as a consequence of the functionality formed in the previous step. Fogg added further stipulation to this definition that all the transformations involve a single catalytic mechanism, as shown here in the scheme 1. Domino-Heck reaction. Domino-Heck reaction is a palladium-catalyzed coupling reaction which involves the formation of new carbon-carbon bonds and have frequently been utilized in the cascade processes. In 2008, Yu and co-workers reported the synthesis of tricyclic lactam via two consecutive Heck reactions followed by CH activation step using diene. The process begins with the reaction of the palladium catalyst with aryl bromide. The first reaction occurs with the alpha beta unsaturated alkene and the resulting organopalladium intermediate, which undergoes a second Heck reaction with the substituted alkene. Finally, the carbon hydrogen activation step takes place with the adjacent aryl system to furnish the tricyclic product in high yield. Metathesis reactions. Metathesis reactions also play a very important role in the organic synthesis in addition to the palladium catalyzed coupling reactions. The group of Schrock and groups reported the complexes of molybdenum and ruthenium respectively, as well defined metal centers for the catalysis of metathesis reaction in the year 1990s. The stability of the ruthenium catalyst has made metathesis reaction a popular choice for incorporation in one-pot reactions. Since then, the carbon-carbon bond formation using cross metathesis, that is ring opening metathesis and ring opening metathesis polymerization, as well as construction of these cyclic systems through the ring closing metathesis, has been very extensively used in organic synthesis and in the total synthesis of the numerous natural products. In 2002, Stapper and Bleckert utilized a metathesis cascade towards the total synthesis of plus dihydrocusohygrine, which as shown here in the scheme. Firstly, diamine 3 was synthesized in 9 high yielding steps from tropone. Then treatment of 3 with group's first generation catalyst initiated a ROM reaction of the 7-membered ring system, followed by the 2 consecutive RCM reactions with the 4 alkenes. The unsaturated bicyclic product was immediately subjected to hydrogenation and bis pyrrolidine 4 was yielded in 72% over the 2 synthetic steps, comprising of the 4 individual transformations. Reduction of dicarbamate 4 followed by deprotection of the TBS group afforded the natural product 5, very clearly depicted here in the scheme 3. As catalytic domino and cascade sequences utilize one catalyst and one catalytic cycle, therefore, the diversity of the process can be limited. Furthermore, as all the functionalities required by the process is present in the starting material, the potential of transformations taking place out of the sequence is increased and could potentially lead to the poorly defined products. By designing a one-pot process that utilizes 2 or more catalytic pathways, the directionality of the processes can be made more reliable. Tandem catalysis. In Fogg's classification, tandem catalysis is described as a sequential transformation of the substrate via two or more mechanistically distinct processes. The transformations can be effected by using the same catalyst, that is autocatalysis, or via different catalyst, orthogonal catalysis, as shown here in scheme. Fogg also stipulates that tandem reactions take place under the same reaction conditions and without addition of the substrate or catalyst after the reaction has been initiated. One-pot reactions that require an addition of catalyst or reagents after a reaction has commenced, or sometimes referred to as assisted tandem or sequential reactions. These tend to be more prominent in the literature due to compatibility issues which can exist between the catalyst. By allowing one catalytic process to take place before the addition of the second catalyst, these issues can therefore be avoided. For clarity, the term tandem catalysis will be subsequently used to describe all one-pot catalytic processes that involve two or more distinct processes regardless of when the catalysts are added or whether the reaction conditions are altered during the process. As highlighted in the previous section, metathesis reactions have been a popular tool for the construction of the carbon-carbon bonds for the past 2 decades, and many of the ruthenium complexes used to catalyze these processes are commercially available. More recently, however, research into the non-metathetic uses of these catalysts has been published. Examples include atom transfer radical additions, Kharas addition, double bond isomerizations, oxidations, reductions, cyclopropanations, the Diels-Alder reactions and the Wittig reaction. Furthermore, by combining a metathesis reaction with these non-metathetic steps, more diverse tandem processes have been developed. One of these is explained here in this section. Kharas addition. Lactams are found in an array of natural products and act as an advanced intermediates for the synthesis of antibiotics and anti-cancer reagents. As a result, new methods to synthesize beta, gamma and delta lactams are of interest in organic synthesis. Methods that can form the lactam system are in ways other than through the formation of the amide linkage are particularly interesting. In 1984, Ito and co-workers reported the synthesis of gamma lactams through ruthenium-catalyzed Kharas cyclization of allylic trichloroacetamides. In all the cases, only the gamma lactams were isolated in high yield, showing a preference for a 5-exotrig cyclization over the 6-endotrig cyclization as shown here in the figure. A general mechanism of ruthenium-catalyzed process has been proposed. The ruthenium-2 catalyst initiates the process by abstracting a chlorine atom from the trichloro group of the substrate 6 to form a carbon-centered radical as shown in the scheme 5. This radical then undergoes a 5-exotrig cyclization to form a 5-membered lactam ring as shown in the structure 7. Finally, quenching of the terminal radical occurs with the reduction of ruthenium-3 to ruthenium-2 to complete the catalytic cycle. In 1999, Snapper and co-workers reported that the group's first generation catalyst was a mild and an efficient catalyst for the Kharas addition reaction. Whilst conducting a CM reaction, they isolated a product which had been formed from the chloroform addition across the double bond of the parent olefin. This unexpected result indicated that the group's first generation catalyst could catalyze a Kharas addition reaction. To conclude, the use of metathesis reactions catalyzed by the group's alkylidines has become popular tool in the organic synthesis for the formation of carbon-carbon double bonds. More recently, these metathesis catalysts have been found to catalyze a wide range of non-metathesis reactions, including oxidations, reductions, cyclopropanations, as well as the named process including Wittig and the Diels-Alder reactions. Furthermore, the combination of these novel uses in the tandem with the metathesis reaction has become an active area of research and development, with many one-bond processes that utilize one catalyst to effect two mechanistically distinct processes being reported. These processes have huge environmental advantages as they allow the transformation of the simple substrates into the complex products in one pot procedure without a need to isolate intermediates. This ultimately reduces the time taken to carry out the reactions, the solvent usage and the overall waste production for the tandem processes. Finally, a planning for retrosynthesis has been given in a tabular form as follows. The overall goal of antithetic analysis: decrease complexity, reduce size, cyclic connectivity or topology, element or functional group content, stereocenter content and or density. Remove centers of high chemical reactivity, centers of kinetic or thermal instability. Second, characterization of powerful transforms. Most powerful: disconnect, molecular skeleton, chains or rings. Keep in mind Diels-Alder, Robinson annulation, aldol, Dickmann cation, pi cyclization, internal SN2 transforms. Remove or disconnect functional groups and stereocenters. Replace functional groups with hydrogen, that is carbon hydrogen activation, CH oxidation, CH functionalization, etc. Cascades, tandem and domino strategies fall into this category. Non-simplifying transforms, which are moderate, molecular skeleton, connect or rearrange, that is oxycope or pinacol rearrangement, functional groups, interchange or transpose, that is masking with the Neff reaction, isomerization, 2,3 rearrangements, stereocenter, invert or transfer, that is epimerization. Try to use in tactical combination with the powerful transform when possible. Transforms that increase molecular complexity: add, rings, functional groups, stereocenters, protecting groups, activating and deactivating groups and temporary bridges. To summarize, tandem reactions involve the formation of several bonds in sequence without altering the reaction conditions, adding different reagents and isolating the intermediates. It allows the organic synthesis of complex multi-nuclear molecules from a single acyclic precursor. Tandem reactions are classified into three categories: cascade or domino reaction, which is a consecutive reaction and a sequential reaction; stereoselective synthesis of bicyclic gamma lactams having been developed by tandem process. New methods have been developed for formation of the new carbon-carbon bonds, for example, palladium-catalyzed coupling reactions utilized in the cascade processes. Metathesis reactions also play a very important role in the organic synthesis in addition to the palladium-catalyzed coupling reactions. Tandem catalysis involves sequential transformation of the substrate via two or more mechanistically distinct processes. In 1984, Ito and co-workers reported a new method of synthesis of gamma lactams through ruthenium-catalyzed cyclization of allylic trichloroacetamides. Practically, tandem reaction focused on reduction of waste, avoid isolation of intermediates, reduces labor and academically proven to be builds a larger degree of complexity in one transformation, novel avenues of research and new reaction developments.